Section 5.3, we are talking properties of logs. Say there are 7 boxes. You need your calculator for sure. All right. You guys ready to go? Yes, you are. Okay, so let's begin by talking about first something I think I already did talk about earlier, but we're going to explore a little more. Talk about the change of base formula. The change of base formula. So here is what it says. It says something pretty neat. If we have log with a base A of B, we are allowed to rewrite this into any base that we want. So that means that we have 2 convenient bases that we could use for our calculator, right? Whenever we push the log button on our calculator, we have a base of 10. We can also use the natural log button on our calculator, which is a base of E. Turns out they both work just fine when using the change of base formula. And then those of you with fancy schmancy calculators, you can use math alpha math, right? That will also get it to you. So here's what it says. It says that log base A of B is equal to log base 10 of B divided by log base 10 of A. Now we don't necessarily need to write the tens whenever we write a log. If we write a logarithm without a base, it's assumed to be a base of 10, but I'm doing it for emphasis right here. We could also write this as the natural log of B divided by the natural log of A, because after all, it's the same base, or a natural logarithm is a logarithm with a base of E. So this will work for base 10, and this will work for base E. Put in that in. Okay, base E. So let me give you an example of this. So here's the change of base formula. So let me give you an example. Let's say I want to figure out what is log base 4 of 25. Okay, log base 4 of 25. Well, what does that mean, log base 4 of 25? It stands for something. What does it actually represent? Yes. What do you think, Nels?
Log base 4. Wait, what do you mean?
Like log base 4 of 25, it actually represents a number, right? So Justin says, so what to the?
4 to the x is equal to 25.
Good. So this says 4 to the what power would give us 25, right? Nice job, Justin. So at 4 to the what equals 25. So let's think about this. What's 4 to the first? 4. What's 4 squared? 16. What's 4 to the third? 64. So the answer needs to be between what 2 integers? Between 2 and 3. So it has to be closer to 2 than into 3. How come? Because 25 is closer to 16 than it is to 64, right? Okay, so we think the answer is somewhere between 2 and 3. Okay, so let's use the change of base formula. We can go 2 routes with this. We can either say log base 10 of 25 divided by log base 10 of 4, or we could do this. The natural log of 25 divided by the natural log of 4, okay? We're going to do both of these on our calculators right now to show you that we should get the same answer, okay? So here I turn my calculators on, and you can see that I have it in there from before. I had log 25 divided by log 4, and that gave me 2.32, or I did natural log 25 divided by natural log 4, that also gave me 2.32. Which makes sense because we said our answer needed to be between 2 and 3. All right, logarithms, there are 3 basic properties of logarithms that we're going to be responsible for knowing and knowing how to use. And we're going to be expanding logarithms and condensing logarithms using these 3 properties. Okay, so there are 3 of them, so I'll label this out for you. 1, 2, 3. Leave yourself a little bit of space in between. And we'll talk about each one of these. Okay, the first one is called the product property. The product property. Okay, so product property, what do you think that means? What does the word product mean?
Multiply.
That means multiply, right? Exactly. So the product property says that if we have log base A of 2 quantities being multiplied together, like log base A of x times y in this particular case, okay? Do you see the product?
Yes.
It's right in the middle there, right? X times the y, all right? Well, it's allowing us, the property says that we are allowed to take log base A of x and add it to log base A of y. Because remember, a logarithm is nothing more than an exponent, right? And when we are multiplying exponents with the same base, we add their degrees. That's why we're allowed to do this, right? This follows. The next property is called the quotient property. Okay, so if you think about this, if multiplication can be expanded over addition, then it must be the case that division should be expanded over subtraction. You got it. Exactly. So if I take log base A of two quantities like x divided by y, I'm allowed to expand it through division. So that's log base A of x minus log base A of y. Okay, the power property says if you have log base A of b raised to some power of m, then it is allowed to, the m is allowed to be brought down in front of the log to give us m times log base A of b. That's the power property. So your power is allowed to jump down in front. So here are the three basic properties that we need to be responsible for when we're dealing with logarithms, okay? They are the product property, quotient property, power property. These are the three that we have to be able to be responsible for. So some basic examples here to deal with, to begin our exploration of logarithms. So we have log base 6 of the fifth root of 6. Okay, now if you take a look at the board over there behind Bobby, notice I have the square root of x is the same thing as x to what power? The 1/2. The cube root of x is the same thing as x to the 1/3 power. So the fifth root of x must be x to the 1/5. Okay, good. So that means that we can rewrite this as log base 6 of 6 to the 1/5 power. So now I have a power rule, yeah? That power rule means that this 1/5 is allowed to come down in front. So I have 1/5 times log base 6 of 6. What's log base 6 of 6?
1.
It's just a power. It's just 1, right? We know that one from before. So that means that this is equal to 1/5 times 1, or just simply 1/5. What do you think? Easy, medium, or hard? Easy, right? I think so too. Okay, let's take a look at B. It says the natural log of e to the 5th minus the natural log of e squared. Well, I have two power rules here, right? This 5 is allowed to come down in front here. This 2 is allowed to come down in front here. So I'm going to get this. 5 times the natural log of e minus 2 times the natural log of e. But wait a minute, what was the natural log of e again?
2.7.
Remember, natural log of e. 1, very good. This is 5 times 1 minus 2 times 1. Don't forget, remember, natural log of e is the same thing as log base e of e, and anything that gives us power of 1. So I'm going to get this, 5 minus 2, so I'm going to get an answer of 3. There's a power rule and there's a product rule for part A. So what we're going to do is we're going to expand inside the parentheses first. So we're going to have something that looks like this. We'll have log base 7 of 5 plus log base 7 of x to the 4th plus log base 7 of y. So do you see how, because I had 5 times x to the 4th times y, there was like three product rules right there? So I'm going to expand, so now I have log base 7 of each of those. There's only one more thing to do, and that is to bring this 4 down in front of the second log term, not the entire thing. That's a common mistake that people make. So I'm going to have log base 7 of 5 plus 4 times log base 7 of x plus log base 7 of y, and that will be our final answer. So when you take a look at part B, what do you notice right away? Are we dealing with a product rule or a quotient rule?
Quotient.
A quotient rule, right? And then we also have a square root. So breaking this down, I would have the natural log square root of 8x minus 3 minus the natural log of 5. Now, why is it a subtraction sign there, everybody? Because it's a quotient. Yeah, exactly. Okay, there's something I need to do now with that square root. How do I rewrite that square root?
You multiply to the 1.
Yeah, to the 1/2. Nice job. So that's going to give me 8x minus 3 to the 1/2 power minus the natural log of 5. Now, the power rule says I'm allowed to bring down in front. So I'm getting 1/2 times the natural log of 8x minus 3 minus the natural log of 5. And that would be as far as I could take that one. Okay, in your table groups, go ahead and expand the natural log of x, y, z to the 5th. X, y, z to the 5th. Expand it. Go for it. So you should have had natural log x plus natural log 5 plus 5 natural log z. All right. Before, what we were doing is we were taking the logarithm and we were expanding it out. Now we're taking an expanded logarithm, we're condensing it down to a single logarithm. So the directions may say something like write as a single logarithm or condense the log. So what I see here is I see a product rule in reverse and a power rule in reverse, right? Do you guys see that? So the question, a couple of questions I have for you is, this 1/2, where did it come from?
Square root.
It came from the exponent on the x. This 3, where did it come from? The exponent on that. And I am adding the two things together, so that means I'm going to use the product rule. Good. So I should have this. Log base 10 of x to the 1/2 plus log base 10 of x plus 1 to the 3rd. Since I am adding those logarithms, they can be condensed through multiplication. So that means I'm going to have log base 10 of the square root of x times x plus 1 to the 3rd. And now I have rewritten it as a single logarithm. So 2 natural log of x plus 1 minus the natural log of x. Okay, so question for you. Where did this 2 come from? From the power, good. And what am I doing to these two logs? Subtracting them, so we're going to use the quotient rule, right? So that means I'm going to have this. I'm going to have the natural log of x plus 2 squared minus the natural log of x. That will give me the natural log of, sometimes the book will use brackets. We'll do an x plus 2 all squared divided by x in brackets. And there is my final answer.
Do you have to distribute that?
Ooh, look at this one. This says 1/3 times the entire log base 2 of x plus log base 2 of x plus 1. Okay, so now in this case, the 1/3 is being applied to the entire expression, right? The entire logarithm. And I'm using addition, so that means if I go in reverse, I'm going to have to use the product rule, right? So this whole, I'm going to work inside the parentheses first. So this is going to give me 1/3 times log base 2 of x times x plus 1. Does that make sense so far? Yeah. Everything's good so far? Yeah. Then where did that 1/3 come from?
Power.
Yeah, it came from the power, right? So this 1/3 came from the exponent on the logarithm. So I'm going to have log base 2 of x times x plus 1 all raised to the 1/3 power. But we don't leave it like that in 1/3 powers. We leave it in terms of what? Instead of 1/3 power, cube root. Very good. So we would have log base 2 of the cubed root of x times x plus 1. Which looks a lot cleaner, huh? Yeah, good. I'm glad you guys are looking at this. So this says 2 times 3 natural log x minus natural log x plus 1 minus natural log x minus 1. So there are there are 2 subtraction signs. So the question is, how do we rewrite that as a division, right? So the trick is to make the last 2 expressions factor out a negative sign. So here's what I mean by that. So here's the trick. We'll do 2. 3 times the natural log of x. We'll do minus. Inside here, I'll have the natural log of x plus 1 plus the natural log of x minus 1. So you see what I did there? I took the last two, I factored out a negative sign. You guys see the algebra there? Yeah? Yeah, that's a good thing for us because now I'm going to work inside that second set of parentheses only. So that's going to give me, this is going to equal this, it's going to give me 2 times 3 times natural log of x minus, parentheses, the natural log of x plus 1 times x minus 2. So now I've condensed that second part into a product of x plus 1 times x minus 1. Oh, sorry. Thanks. That should be a 1. Good job, guys. Way to catch that. So far, so good? Okay, now, does anyone recognize x plus 1 times x minus 1? Do you guys recognize that at all?
X squared. There's a word.
Very good. The difference of two squares. Nice job. So that's going to be 2 times 3 times natural log of x minus, this is going to give me the natural log of x squared minus 1. Now we're looking pretty good. Do you see what we've done for ourselves? We've taken this problem from 2 minus signs down to 1 minus sign. That's good for us, right? Because yeah, exactly, right? It's the we've got now we have a quotient here, right? Because x plus 1 times x minus 1, that's x squared minus 1, right? Good. So then we're going to have this. We're going to have 2 times 3 natural log of x, but then we're going to be dividing. I'll try it again. Natural log of x squared minus 1. That didn't help me very much, huh? Sorry. Yeah. I just rewrote the whole thing. This is what I meant to do. Natural log of x to the third minus the natural log of x squared minus 1. There we go. Sorry about that. Wrote an extra line of algebra there. Because this 3 came from the exponent on the x. There we go. Now I'm going to have a quotient. So I'm going to say 2 times the natural log of x to the third all over x squared minus 1. And then lastly, where did the 2 out in front of the entire natural log, where does that go? You got it. Squared on the whole thing. So this thing comes back up to there. So for the final answer, I get the natural log of x cubed all over x squared minus 1 quantity squared.